In this video, I'm going to show you guys a little bit about how to use Kisslicer slicing software in a very basic mode. I'm not going to get into a lot of detail about the hows or the whys of the different settings. I'm just going to show you how to set it up to print, to slice effectively for a Cerberus 250, a Cerberus Mega, and a Cerberus Pup as well. So let's get started. So if you've got Kisslicer, I actually have the registered Pro version. It gives me a couple of extra features, but you don't really need to have the Pro version if you're just doing basic slicing. And we'll start with setting the printer up. So you can see at the bottom there's a number of tabs: Style, Support, Material, Material G-Code, Printer G-Code, and Miscellaneous. First thing I like to do is get the printer set up. So in this case, normally you start with default, and at that point you can click on Copy Printer down here. It copies the default profile into a new profile and allows you to change the name. So once you've done that, you'll be able to type in whatever you want to name your printer. It doesn't have to be Cerberus or anything like that, but in this case we're going to go Cerberus Pup 180, and that has one extruder. If you have multiple extruders, you can add them here. And then I just give it the bed size, and I'm just giving a bed size of 165 by 165 by 137. And these are not hard coded to your firmware or anything like that. It's just basically to give you the outline of the shape on the screen. It doesn't give you a circular shape, but generally speaking, side to side is 165, so just round the corners off. The bed roughness, the Z settle, and the Z offset are all set to zeros. And I like to do a 0.88 loop, solid loop infill overlap, so your infills will basically touch the perimeters by a factor of 0.88. And if you roll over and hold your mouse on top of any one of these, it gives you a little bit of a description. It's actually kind of a nice little thing. Let's move on to firmware. Deltabots are all absolute E firmware. Normally when you have it, when you first install it, it's going to say relative E, but you want to change that to absolute E. Include comments. I found there's actually possibly a bug where if you disable the comments, all your start G codes get put onto one line together and it doesn't work properly. M106 for the fan on, M107 fan off, and the fan can do PWM. And if you have a post process, you can add it here, but we're not going to talk about that right now. For the extruders, the material when you first get here is going to just say default and just leave everything the way it's set up. And then for speed, I like to do a slow perimeter of 25, solid infill of 35, and a sparse infill of 40. That's on the slow speed. I'll show you the slider here in a second. And then for fast speeds, it's a 50, a 90, and a 105. And then my XY travel speeds are set to 180, 180, and I do a 20% maximum, 20 millimeters per second maximum travel speed on the first layer. So a little further to your right here, you can see there's actually a control for the speed of the printer, and you can go from fast and crappy to precise and beautiful. And I pretty much keep it over on the precise side. I don't really ever end up needing to have parts in 5 minutes. I just I'll set something to print and I'll walk away and do something else for a while and come back and it'll be done. And I do like to keep the expert setting on here. Alright, so once you've got your printer, it saves it automatically, by the way. Anything you type in here just gets saved. You don't have to hit save or anything like that. Next we're going to move to style. And once again, it's always starts out on the default, and I hit copy style right away. And I'll do different styles. I don't have a lot of them on this particular computer. But for instance, if I'm doing Cerberus brackets, I look over here first on the right hand side for layer thickness, and I'm doing a 0.2 millimeter layer thickness. And then I look over on the left side, and skin thickness is set to 0.6 millimeters. So if you have each layer being 0.2 millimeters thick, and you've got a total skin thickness of 0.6, that means you're going to get 3 layers down. So on any surface that's on the bottom or top or any flat surface, you're going to get 3 layers. And then number of loops is set to 3 as well. And that, of course, is multiplied by the extrusion width, which in this case I'm using a 0.5 millimeter nozzle. And that means that I'm going to get a 1.5 millimeter total width for all of my perimeters, which are all the vertical walls. Okay, let's see. Cerberus brackets, I'm typically keeping those at 33, and I like to do the straight infill. It's pretty straightforward. Loops always go from inside to perimeter as far as I'm concerned, because anytime you have only special cases where you don't have any overhangs or any outward facing, any outward sloping print surfaces, you can imagine that if you had loops going from perimeter to inside and you had some kind of a print job that was sloping like this, you'd print way out here first and then print in midair, and then you'd have to print closer to this direction. Basically your print's going to fail. So I always print from inside to perimeter. That way you get a perimeter, and then you get another little layer out, another little layer out, and so on and so forth. It works a lot better. And I always do D-string. You need to do D-string on these Bowden setups, because you have to release the nozzle pressure when you're doing travel moves. Otherwise you get a lot of stringing and blobbing. So let's move on to support. I actually normally design all of my parts so that I don't have to have any support. Every once in a while you can't get away with that. So I typically keep it on dense, and then I just change the support degrees. And what the degrees is, if you have any object, I should load something up here. Let me just drag something in here. Let's see here. Come on. Why is it not? There we go. Okay. So it's a drag and drop. You'd find an STL file and you just drag it into place. You can see this is one of the corner brackets for a Cerberus Pup. And you see this little overhang here. If you were looking at the plate, there's absolutely nothing between the plate and those lines up there. And you're like, well, that needs to have a support in there. Well, actually, I don't print them with support because the Cerberus Pup can basically bridge that, and it can do that without needing any support, which is kind of nice. But if you did need support, that's considered a 90-degree support straight across. So it's 90 degrees off of vertical. Now, if you wanted a support to come along this little angle over here, and I think that's something like 60 degrees or something like that, then you would have to set this to just under 60 degrees so that it would read the fact that you want support on something to be at 60 degrees. And you can keep going down 45 degrees and so on and so forth. You just have to experiment with that. The other thing is the support Z-roof. Okay, no support will be generated above this height. So if you have a product that only needs support for the first couple of layers, or there's something down there that you really want to have a nice opening that's supported really well, you can say after 5 millimeters, don't print any more support, and that's going to stop printing support at that point. I like to print a skirt around the print. So if you look at this from the top view, a skirt basically, on the very first layer, it just runs a bead of filament around. It's extruding a initial bead to get the extrusion primed and operating correctly. It's just a good idea to do that. And I inflate it 2 millimeters beyond the edge of my print. Let's move on to material. Every material is a little different. And I actually print almost exclusively in black PLA. I kind of like the black PLA. It's good stuff. I use SaneSmart or ZenTool Works. There are a lot of other really good brands out there. But this particular brand of PLA, you have to measure every roll of filament you get. You got to get a calipers, and you got to measure it in multiple places. This one averaged out to 1.74 millimeters, and it prints really well at 195 degrees. It's trial and error on every single one. You have to just print a test piece every time you get a roll of an unknown roll of filament. You got to do that. So the D-string. So remember over here on the style, I had the D-string checkbox. Well, over here under material, you can do different D-strings for every single material. Now remember, you can start with a default material. You hit copy material over here, and you can basically tell it, you can give it a name, black PLA, white PLA, ABS, etc. You can see my numbers here for this particular material. Once again, they're all a little different. Prime is 5.9 and suck is 5.85. I always do a little bit of additional prime. The suck is when it retracts, and the prime is when it pushes the filament back into the nozzle. And so it retracts so that it releases the pressure in the nozzle so that it doesn't string as it travels, and then it primes back in to get the filament back into the nozzle so you can start printing again without having too little filament in the nozzle. You get bad prints that way. And I retract at a speed of 200 millimeters per second. That's about as fast as I can get that little stepper motor to go. My minimum jump is set to 5 millimeters, and my trigger is set to 20. You can just play around with those if you want to. I have the fan coming on pretty much at 0, but a lot of times I'll set that to 0.4. So the first 2 layers. Now once again, you have to know that your layer thickness is 0.2 millimeters. That way when you come to your material, you'll know that after the first 2 layers, which is 0.4 millimeters, then you're going to have the fan turn on. So the part cooling fan gets turned on after the first 2 layers. And if any layer would go faster than 10 seconds, it slows the head down so that it hits 10 seconds. And actually, I run it about 6 seconds. And I like to do a little Z-lift. So every time the machine does a move from one location to another and it does the D-string, it's basically going to lift the nozzle up by half a millimeter as it travels, so it doesn't get caught up on anything as it's traveling across. I just leave the flow adjust the way it is. That's a little bit more advanced. You can mess with that if you want to at a later date, but for this particular tutorial, we're not going to worry about that. Okay. Material G codes, I don't ever do anything with that, but I do work with the printer G code. Now, for a single extruder machine, you really only need to worry about the prefix, which is also called the start G code, and the postfix, which is called the end G code by some other slicers. And for the prefix, this is basically prepended to all of the G codes that are sliced, and you'll see these after the initial comments in your G code file. You have to scroll down a couple of pages to get to them. I do a home, and then I make the nozzle move down and off to the side of the bed, right down against the edge of the glass before it does the preheat. And then what happens is the nozzle will heat, and a little bit of filament's going to just come oozing out of the tip. And I've put it down there at the edge of the bed, and so what happens is as soon as the print gets going and the platform moves to start the print, the little piece of filament gets hung up on the edge of the glass, and it gets cut off. And that way you're not dragging a little piece of filament around with you that might get caught up in your print at some point. Okay. There's actually a little semicolon right there. This is the method for commenting things out in G code. You put a semicolon in the front of it, and it will not be read by the interpreter. And the next line is an M109, which is heat the extruder and wait. There's also an M104 command, and you can sometimes put that at the beginning after the G28. You can set M104, which is a heat and continue. So, but in this case, I just it gets to that corner so fast it doesn't matter. So M109 and then S, and then this bracket temperature end bracket, and that basically gets replaced by the I think it gets replaced by the first layer code that you've set for your material. So in the printer G code, that bracket temp is a special code that reads in the temperature for whatever material you've got set up. So don't hard code that to some temperature. Let the material set the temperature for it. And you can see over here there's a couple of different commands that are special codes that you can use to set that up there. And then I keep this around just in case I want to do a G29, which is the bed leveling. But for the most part, these printers are so rock solid, they don't really need to be calibrated that often. Actually, I haven't calibrated one of my printers since I first calibrated it 7 months ago, so it's been running pretty well. The G29 though, if you're going to run a G29, I actually will tell you to add an offset of Z minus 0.35, and that seems to put the nozzle at the correct location. There's probably a way to adjust that inside of firmware, but this just seemed like a sort of a convenient way for me to do it, and I'm a little bit lazy that way. Alright, select extruders, this is all commented out. Deselect extruders, all commented out. You could literally delete that stuff if you don't ever plan on having any extruders. And have it do something every number of layers. I don't mess with that at all. And then postfix, I like to home the printer after I'm done. M104S0, that sets the temperature to 0. M140 turns off the hotbed. We don't have one. That should actually be commented out. And then M84 disables the motors, and that's the end of your G-code. And that's all you got to do. I wouldn't worry about the... I don't think you can set any of this stuff up if you don't have the Pro version of Kisslicer. But once you've done that and you've got this set up, you can come up to the top and you can hit the slice command. Now, I have a really high-end video card on this machine, and for some reason the preview doesn't show up. I don't know why. I got one of those workstation class cards for my SolidWorks. So it looks like it goes blank here, but on most computers and all of my other PCs, it'll actually show you a little progress as it goes through, and it's very, very fast, much faster than Slice 3. Or it just blows almost all the other slicers away as far as speed. Now, once you've sliced it, it changes color, and then you can click on these buttons across the top here, models and paths. Right here, it gives you a very faint outline of your model, and then it shows you the path. That's the first layer, and you can see that's that prime under support. That's that raft, the skirt, and it's 2 millimeters out. You can see that yellow line going around right there. And you can scroll up and you can see that I have a 33% infill. We'll get a little closer. Well, I'll show you the infill in a little bit here. But you can see this part's all set up, and it's going to slice real nice. But you should definitely look for overhangs and things that suddenly appear in midair that shouldn't be there, like there. See how it's totally open here, and then the next thing you see is that layer right there. Well, luckily it does this perimeter first, and it basically bridges that whole thing, and then it comes across and it basically infills that whole thing, because I've done. And the reason that works, as far as I can tell, is under printer, under hardware, I've got the loop to solid infill overlap set to 0.88, and that allows the nozzle to come and touch the filament as it's come across right there. Anyways, that's how that works. And if you drag this slider all the way back down to the bottom, it'll actually show you the entire G code in slices like that. It's kind of cool to look at right there. And then finally, you can let's see. You can also turn off the show settings, and you can go to paths, and this shows you from a top view. And then you can really get close in there with your observation of the G code. So there you go. That's what you're looking at. And once you verified you like it, you would hit save. And you just basically save out your G code to a known location, and then you're ready to go over to repeater host and open that file up. And I guess we can do that right now. Minimize that. Here's repeater host, and we're already connected. I'm going to hit load, and here's a bunch of stuff that's already been sliced. You can see it's a G code file, and we're going to open this thing up, toggle the log, and I'm going to zoom in a little bit here. Move around so you can see what we got. That shows you all the travel moves can be turned on and off up here. The filament can be disabled on and off here. And then you can also, at the bottom right hand corner, you can say show single layer or show layer range, which is kind of nice for just observing how the layers are gonna run up like that. You can do a show layer range as well, and you can drag the slider like this, so that'll show you basically a layer range. Okay, and then this in the G-code editor window. You'll see it says G-code right there, and this is the G-code that we've loaded. And the first long while gives you all the information about the settings that we've got set up, and then you come on down and it changes color. Then here you can see the M104 S200 G28, and then it moves to there, etc., etc. And then this is all the G code itself. Now, if you did show single layer, and we went down to the first layer like this, what's kind of cool is if you have this little eyeball, there's a little auto update preview over here, and then if you start to highlight this, just watch. You can actually watch the G code being printed out here. So if you need to find something, there's something wrong with your G code, you just want to come in here and make a quick change to it, you can just come in here and change it that way. All right, and that concludes our Kisslicer into repeat your host G code generation. Thanks for watching.